Okay. According to schedule, you will take quiz number 4 from chapter 9 on Wednesday. As you know, practice problem and previous quiz number 4. So with the example question, practice problem, and previous quiz number 4 question, prepare well, please. And when you do prepare, if you need a previous quiz number 4 answer, then email me, then I will send you the answer. Okay, any question about quiz number 4? Not, then today's lecture, chapter 12. Okay, chapter 12, JIT and lean operations. JIT is just in time. Definition of just in time. An approach of continuous and pursuit problem solving by focus on throughput and reduced inventory. From the JIT, the name, try to reduce inventory, because inventory is kind of waste, unnecessary inventory. Actually, inventory itself is necessary, but unnecessary inventory, like an over inventory and so on. So try to reduce waste and then produce more. So just in time is an integrated set of activities designed to achieve high volume, produce more using minimal inventory. Inventory are raw material, work in process, finished products, component, and so on. And just in time is pull system. Pull system, I will explain what is the pull system in next slide. Nothing will be produced until it is needed. Just in time, in just-in-time system, nothing will be produced until it is needed. I think this is familiar. This is make-to-order system. So don't do anything, but when customer place order, then start produce that order. That is a make-to-order system. Just in time system use make-to-order system. And pull system. Pull system, inventories are pulled through the system by actual demand. Make-to-order system. Just in time system is a pull system and make-to-order system. When a customer place order, Then this final assembly station or department doesn't have a final product. So ask product, and then ask part, and ask part, ask part. Then supplier, send part like this. So this one asking part, that is for part or component. Asking upstream need part. So asking is kind of a pulling part or inventory. So pull system, inventories are pulled through the system by actual demand. So actual demand, ask part, so pull inventory or part. So that is the pull system. And then push system, the other side. Demand is forecast. Demand is forecast. Inventories are pushed through the system to satisfy the anticipate demand. That is now make to stock system. Just in time system use a pull system, make to order system, and then other traditional system or MRP system. Earlier we covered the MRP system. So MRP system is traditional system, and then use push system, make to stock system. By forecasting, they know demand. So to match that forecasting or demand, just make and then send down to downstream. So inventory or part, just push down like this. So we call this as push system. So push system, traditional system, MRP system, use push system and make to stock system. And in JIT system, the elimination of waste in production efforts. Okay, here I can ask you what can be waste in production system or production efforts. Something unnecessary or excessive or kind of waiting time, break time, unnecessary space, unnecessary process, and so on. So in JIT system, try to eliminate or get rid of unnecessary things. And then the timing of production resources. In JIT system, time is very important because if I need something now, but it delay, like tomorrow and take time, the waiting time or delaying time can be waste. So like the name of this system, just in time, time is important in this system. The Toyota production system, simply they call a TPS, Toyota production system. Hyundai called this JIT system as just in sequence. Hyundai called JIS, the same JIT system. In Toyota production system, how they eliminate waste. So using focused factory networks. This one is a small specialized plant that limit the range of product produced. Sometimes only one type of products for an entire facility. I never been a Toyota plant, but I've been Hyundai and Kia plant. So example, Hyundai and Kia case. I will draw like a map. Then here, like a Georgia and Alabama border. Then from Atlanta to Montgomery, there is Highway 85. And here, 65. And this Montgomery, Alabama area. Hyundai is about here. And then Kia is about here. And then near the Hyundai, there are many suppliers. And then near Kia, there are suppliers. And then also along this I-85, suppliers. Then one of the Hyundai here supplier, the company produce circuit board inside of the door panel. So this company produce circuit board, and then send it to this another supplier of Hyundai. This company produce door panel. And this company produce instrument panel, send it to another supplier of Hyundai. This company produce the dashboard and so on. So they are connected each other, and then connect to Hyundai and so on like this. And then they also connected each other like this. So it looks like network. And then those suppliers are small specialized plant. Then sometimes not only one type, like a circuit board, a door panel, instrument panel, dashboard, and so on. So we call this as focused factory networks, because they are located around the main company, the final assembly company. So reduce lead time, and then response quickly, and so on like that. So using this focused factory network, Hyundai, Toyota, Ford, GM, they can reduce delivery time and then quickly response each other. So reduce time, unnecessary time. So unnecessary time is kind of waste. So using this focus factory network, they can eliminate waste, such as unnecessary time, waiting time, lead time, and so on. Okay, next one, group technology. Using group technology, before using a group technology, usually department type or functional type layout, find similar parts or similar common process that make cell, like a grouping. Then they make layout using a cell. We call this cellular layout. Then, before using this group technology, parts or component moving path is complicated. So more distance. But using this group technology, make the process path or process simple. So reduce moving distance and time. So using this group technology, they can reduce moving distance and then simple, make moving path simple. So eliminate time and distance. Quality at the source. Definition, doing it right the first time. When something goes wrong, stop the process or assembly line immediately. So if supplier send a part to next like another supplier or to a main company, send something wrong, then next process or next phase stop. So to prevent that kind of unnecessary like break time, using this inspection at the source or quality at the source. So it's like in the process, like suppliers in the main company and in the main company process, send part to main company or from another to another supplier. After finish its job and then inspect at the source and then assure the product quality and then send. So this one, trust suppliers quality and then without inspection, just produce and then inspect and send. Without inspect, just send. Inspect, without inspect, just produce and so on like this. So many companies use like Hyundai, also many like Toyota, Ford, and GM. Use this quality at source, inspection at the source. To do that, evaluate periodically suppliers. So using a certain criteria. Last time we talked about Six Sigma, quality control, 1 out of million, and so on. So using such criteria, then evaluate, and then give them like a certification, and then trust, and receive, and so on. So using this quality at the source, they can reduce unnecessary time, like inspection time, redundant inspection, and so on. When we say just-in-time production, then it should be right amount. If I need 100 today, receive 200, use 100, and then 100 carry over. So that is inventory. Sometimes excessive inventory can be waste. So if we can receive whatever right amount, then we can reduce or eliminate inventory. So to do that, earlier mentioned about the focus factory network. Near the main company, the delivery distance is short, then they can send small by small, and then frequently, then they can receive or order and receive right amount every time. And then right time. Today I need something. Arrive today, then without delaying or waiting, we can produce right away. So right time is important. And the smaller size. If like a right amount, and then to satisfy right amount and then right time, order small by small. So focus factory network making possible this right amount and right time and smaller size. And then they can achieve this low or virtually no inventory. So if the system can satisfy right amount, right time, smaller size, then they can achieve low or virtually no inventory, unnecessary inventory, then it can be just-in-time production system. Uniform plant loading, in Japanese, heijunka, a firm production plan, uniform monthly production plan. This is simple. Make the same amount of plan schedule. If monthly production plan is like, wow, why is diagonal? So first month 100, second month 50, and then third month like 150. Then this company needs 150 capacity. So this is like 50 and then 100 unnecessary capacity. If the company can't on average, like 100 plus 50 plus 150, 3 months average is 100. So just an schedule evenly, uniformly, 100, then this company needs 100 capacity. So before this 150, this company can reduce by 50 capacity. So this can be unnecessary capacity. Kanban production control system. Kanban means sign. Using instruction card, container, Kanban squares, colored board, such as golf ball or any board. Signal the need for production of a part. It's like buffer between stages, storage area. For this example, this system used 2 Kanban containers. So when starts these 2 Kanban containers full with parts. So this downstream use parts when reach a certain point, then maybe there is a sensor, and then send signal, I need parts. So when receive this upper stage, fill part. During this one is filled, then this one downstream use another Kanban container part. Then when it's empty, then send signal, and then fill like this. So if a system use this Kanban production control system, then they can eliminate like waiting time or break time because of no parts. So using Kanban system, then make it process without stopping. Okay, in JIT system, they can try to minimize setup time. Setup time is preparing time, such as preparing time. If they produce multiple products, then type A come, type B come, and so on. Then they stop and then prepare for another different types of product. So setup time is if they can reduce or eliminate setup time, then that they can reduce throughput time, total time. So question is, how can we reduce, minimize, or eliminate setup time? If they can use separate process line for each different type, then they can reduce setup time. Or if they can reschedule, then they can reduce setup time. It's like that. Scheduling A, B, like this. Then they need 3 setup times between those different product schedule. But if they can reschedule this, then only one setup time. And then maybe they can use, we call that PIP, process in process, or production in production. It's like that. They find, if they can find a similar common process for type A, type B, then a common process using one the same process, and then after common process send to type A, type B, like this. So we call this PIP, production in production, or process in process. Then we can reduce setup time. So many ways to reduce setup time. So use whatever, then reduce setup time. Then they can eliminate unnecessary time, and then reduce total time. Lean implementation requirement. To implement JIT system, there are some requirements. For a JIT system, lean layout and design flow is one of the requirements. Link operations. Operations, they should like a job or a workstation, whatever, they should link together, and then balance workstation capacity. So workstation or process, they should be balanced like this. This one's capacity is like 100, flow like this, then 50, 100. Then this total systems capacity is 50 because of this one, like a bottleneck. So make it 100, then it will be 100. So workstation or process, their capacity should be balanced like this. Then they can reduce unnecessary capacity or waste. And redesign layout flow. You know, like a department type, and then A, B, C, the different types of the product, and then their process or path different. Then something like the path like this. Then if they can use group technology and then make a cell layout, and then they can make like a line type. Then the flow moving kind of a path, make it simple. So try to redesign like this. Then emphasize preventive maintenance. Because of like a malfunction breakdown, that can be waste. So preventive maintenance is one of the requirements in JIT system. And then earlier we mentioned about setup time. So try to reduce setup time. Then reduce lot size. using a smaller size in JIT system to reduce inventory, so reduce order size. So using in JIT system, usually they use a smaller size to reduce unnecessary inventory. Next requirement, this is about smaller size or larger size. Then if they can use smaller size, then total cost reduce. Lean applications for workstation shop. Workstation shop, workstation type, process, many different types of product, and then each type's volume is small or low. Then we need customization. So for the customization of product or goods, naturally, harder to apply this just in time customize the product process. But if we can control demand, then make demand is stabilized, then we can use JIT system, such type of product. We talked about Six Sigma quality earlier last week. So using whatever quality control concept or tool and technology, try to try not to make a defect. So defect or something wrong also waste in JIT system. So using quality control, make better products. So worker responsibility, like quality at the source, using quality at the source, and measure using SQC, statistical quality control. We didn't cover this statistical quality control in this class, but using statistical quality control technique, then quality control, control the quality. And then fail-safe method. We talked about this fail-safe method last week. The automatic inspection, using automatic device to inspect. So using whatever tool, concept, technology, not to make a defect in just-in-time system. And stable schedule. Earlier, we talked about that schedule, level schedule, the same, 100, 100, 100. And then underutilized capacity. Way earlier, we talked about the process, then best operating level. If it is in a production system, using 80% of capacity, and then if it is like a service, human resource, using more human resource, then 70%, using 70% of capacity, that is the best operating level. So try to use best operating level. Then establish freeze windows. You know, like when we book an airline ticket, then like a 24-hour, we cannot cancel like that. So that is kind of a freeze window. So industry by industry, using different freeze window. Sometimes you use 24-hour, 48 hours like that. But like automobile industry companies use 1 month, 1 month freeze window. So schedule earlier, and then before the 1 month, like a 2 months, schedule, they can change, but in like within 1 month, just fix, and then just schedule, just produce, just scheduled. So that is a freeze window. And they work with the suppliers. So in just in time, like using a focus factory network, reduce lead time, then frequent delivery. Because just in time system use smaller size, so frequent delivery is required. And then project usage requirements. When they produce like a new product, they work with suppliers because they need like a new part. And then quality expectation, using or quality at the source. So the last requirement in just in time, work with the suppliers. I think that's all I prepare for today's lecture. Okay, say again, on Wednesday, you will take a quiz number 4 from chapter 9. Prepare well, from my experience, last semester and then earlier semester, students, the average score of the quiz very low. So I ask you prepare well, because relatively quiz number 4 is harder than other quizzes, I think, based on the previous average score. So please practice, prepare quiz number 4 using example question, practice problems, and then previous quiz question. Okay, do you have any question?
I have a question.
Okay.
There should be a practice quiz on Moodle. That's right.
Yes.
I'm pretty sure, right?
I will show you.
Okay. And one more question. On Wednesday, I won't be able to be at my computer about like 4:15. Is that okay?
I don't know if it is your side or my side, and the sound was like like that. So say again.
Okay. On Wednesday, I won't be able to be at my computer until about like 4:15, if that's okay. And then I could start the quiz then.
That will be okay, yeah. Because
Okay.
I think next chapter need like 40 minutes, 45 minutes. So after 40 or 45 minutes, you will take quiz number 4. So it will be fine.
Okay, thank you.
Okay, week of November 9, last week's. No, it's right. Yeah. So in this week, November 9 and then November 15, Moodle shell. In this, you can find chapter 9 practice problem and then previous quiz number 4 question here. Okay. Okay, any other question? Okay, that's all. And see you Wednesday.
Have a nice day.
Okay, thank you.